Okay, this is the second video over types of reactions, and this one I'm going to talk about single displacement and double displacement. So we have 5. The first video covers synthesis, decomposition, and combustion reactions, and so this one covers the last 2. So a synthesis or a single displacement reaction is whenever you have a compound. So that could be, a metal and a non-metal, a metal and a polyatomic ion, 2 polyatomic ions. You have some sort of compound though that's bonded together, and then you have some sort of single element, so a pure element again. Just like with synthesis reactions, how we have those pure substances, so just oxygen or just carbon or just hydrogen. And what happens is the pair and then the single is going to replace somebody in the pair. And so then that person gets booted out. And so I like to think of it as like third wheeling on a date. So there's a couple, and then there's somebody who's single. And then by the end of the night, that person is not so nice and steals the other person's significant other. So now there's a new couple, new bond there, and somebody's left out. And so you can kind of see that from the generic formula. I have a single and I have a pair. And then over here I have a new pair. So now A's with C and B's all alone. Now then, keep in mind that metals always replace metals and non-metals always replace non-metals. So if it's a negative charge, it replaces the negative charge. If it's a positive charge, it replaces the positive charge. So we have some examples of that. So zinc plus hydrochloric acid is going to yield zinc chloride and hydrogen gas. So zinc is positively charged, zinc's a metal, and hydrogen can act as a positive or a negative charge. In this case, it comes first, and chlorine is second, and so it's acting like a positive charge. So zinc's gonna replace the positive charge because zinc wants to be with the negatively charged thing. And so look, it pairs up with chlorine, and then hydrogen's left out. Another example, metal, metal. So the metal's gonna replace the metal. That's exactly what happens. But we have a single, and then we have a pair. And then we have our pair over here and a single. And so it's always switching and replacing. And so that is for if you have metals. And so I also did one over here for non-metals. And so non-metals, it's the same thing. It's the same concept. You have a pair and a single, and you're gonna form a new pair and a new single. And so I have examples. So we have potassium bromide and chlorine, and then chlorine's gonna kick out bromine because metals replace metals, and so non-metals replace non-metals. So since chlorine's a non-metal and bromine's a non-metal, chlorine's gonna replace bromine because they both want to be with the positively charged thing. And so bromine's sitting out. Another example below is magnesium iodide plus fluorine is going to equal magnesium fluoride plus iodine. So they're just flip-flopping places. That's all that's happening with single displacements. So the double displacement is similar, but instead of having a single and a pair, we have 2 pairs. And so the generic formula looks a little different. Not a whole lot different, just a little different. So I have pairs. So I have a pair AB, and I have a pair CD. Okay, a cation always wants to be with a cation, anion always wants to be with an anion, and keep in mind that cations are always listed first and anions are always listed second. So A is listed first, so A needs to stay listed first, and C is listed first, so C needs to stay listed first. Now then, A was with B, it doesn't want to be with B anymore, it broke up, so the only other option is it can be with D. That's the only other negatively charged thing. And then C is going to be with B because it's the only thing that's left. And so that's our generic formula. Now then, we have tons of examples that can fit with this. Off the top of my head, the one that I think of is an acid-base one, but it still works the same. So if I have sodium and I have hydroxide, okay, and then I add hydrochloric acid, I have a pair and a pair. So hydroxide is a polyatomic ion. It's still a part of a pair though. They're gonna form a new pair. So now sodium wants to be with the only negative thing. So if you look, my A and my D wanna be together. So it's gonna be NaCl. And then these 2 things wanna be together. So it's gonna be HOH, which in other words is just H2O. But a double displacement, they're going to just flip-flop partners. And so the positive is going to end up with a different negative, and then the other ones are left out. Another way you can think about it is your outside people pair up and your insiders pair up, if that helps you out a little bit better. But that's a double displacement. So hopefully that's helpful.